Welcome to the building blocks of Altair, video number 2 of the data visualization series on this channel. Now this video assumes no prior knowledge beyond the basic pandas routine and knowing how to install libraries and working with a code editor. Now if you're completely new to whatever I've just said there, I recommend you put a pause here and go to the first video in the series. Otherwise, watch on as we dive into the building blocks of Altair and cover the main essentials that will make the bulk of your data visualization workflow. We'll cover in details data types in Altair, graphical marks, which is the equivalent of geometric shapes in frameworks like ggplot or the grammar of graphics, and finally visual encoding channels. So mastering the three concepts here will make you a highly competent Altair user, as they really are, just like the title of this video, the building blocks of everything you do in Altair. And the difference between Python developers who have learned how to think and conceptualize good graphics and the ones that don't often boils down to the mastery of these seemingly basic building blocks. So detailed timestamps, links, and all of that stuff will be in the video description. And by the end of the video, we'll compose something that looks like this. So you have a slider here at the bottom. You see the select here slider, and as we change the different values, you see that the size would change and the positioning on the x and y axis would change as well. So towards the end of the video, we'll construct a plot like that using everything that we learned. All right, ready? Let's dive in. Let's write some code. So you need some data to start working with this, and we'll go ahead and just do a pip install Vega datasets that comes with some built-in datasets that we could use, and we don't have to go and find ways to generate some data on the fly, right? So we just do pip install Vega datasets. Make sure you're already in the right virtual environment, and let me run that. It says okay, it's already done because I already have that. So I'm going to clear my screen. Then the next thing you do is, if you're in Visual Studio Code, then you want to just create your new notebook, and you do that using the command palette. We talked about this in the last video. So you can say Python, open up the command palette, and then say Jupyter, and you say new Jupyter notebook, right? And it'll ask you for a name, and you just have to create give it a name, right? We don't need that because we already have one. The other way is to just create new file, right-click new file, or click on this icon, right-click or left-click on that, and then just put a name, and then just end the file name with something .ipynb. So it could be anything as long as it ends with ipynb, and that's how the extension knows to recognize that as a Jupyter notebook, and it would open that up in this right interface. Okay, so we already have that. We don't need that now, and let's go ahead and just import all the stuff that we need. We know we need them, right? So go ahead and import pandas as PD, and let's do import Altair as alt, and you will also, since we installed the package which is here, Vega datasets, we might as well bring that in as well at this time. So let's go ahead and just say something like from Vega datasets import data, right? And we don't need the whole data. We only need for this particular exercise, we only need the gapminder data. So I'm going to show you how it looks like. Let me load that in first. So data dot gapminder, right? And just to show you how it looks like, let's print out the head, and there you go. So you have the year, and then you have the country, you have the cluster. We don't know what cluster means right now. We're gonna go into that and maybe investigate it a little bit. And then there's the population. So this population is the population of Afghanistan in the year 1955, and this is the population of Afghanistan in the year 1960, and then this is 1965, and so on. All right. And if you want to just take a look at the hill, you could do that as well. You see the last Venezuela. All right, so population, and then over the time, 1985, 1990, 1995, right? And then there's the life expectancy, and then there's the fertility. So fertility is basically how many kids on average for each woman, right? So one woman, 5 kids, 3 kids, 2 kids. And then life expectancy, that's just how many, on average, how many years, is your life expectancy. That's pretty self-explanatory there. So that's kind of it. This is the data. And once you have those things set up, we're ready to dive into Altair and learn some new stuff. So if you recall, how do we create an Altair chart? We start off by doing the alt, that's Altair.chart, and it takes one parameter here, right? And that's the data frame, the source of data frame. What do we name it? df. So I want to put df in here, and let's start from a point, okay? So let's do a simple scatter plot mark point. And we need to do some sort of encoding. We need to specify what would be the x-axis, what would be the y-axis. So on the x-axis, let's go ahead and just plot out let's take a look at, let's say, the fertility rate, right? The fertility. So we're gonna just go ahead and just say fertility, and then we're gonna have our y, and for y we're just gonna pick a cluster, right? So I want to show you one thing here, and let me just put cluster. So assuming that we're just gonna go ahead and just run this, what's gonna happen? It's gonna show you that, right, it's going to give you grid lines on both the x and y axis. And why is that? Now, the reason for that is when it looks at cluster itself, and it looks at, if you look at the df.dtypes, so df.dtypes, and we spoke about this before, But if you look at cluster, it's actually an integer, and fertility, that's a float. Basically, both of these are quantitative. So even if you did not specify that, right, Altair is going to infer from the data frame, from the data types itself, that this is a quantitative type, this is a quantitative type, and it's going to then create the grid lines for it. So even if without specifying anything like that, it's just going to assume that. So if you put a quantitative here, then everything should still work. But we know that cluster probably doesn't make sense to have that as a quantitative, because if you inspect that, so if you say something like cluster, and you describe that, you will see that it doesn't seem like it's cluster. It has a 1, 3, 5, 5. So really, it's a cluster between 0 to 5, and really shouldn't be a quantitative, right? So because of that, we're gonna change this. Now, we spoke briefly about that, but today we're gonna go into more details, and we're gonna talk about all the different types here. But for in this case here, cluster, we're just gonna have this as a, let's say, ordinal. All right, so we're gonna say this is just gonna be an ordinal rank, and this is just gonna be quantitative type. Quantitative, right? Just run it. Now you see that the grid lines are gone, and also like the aesthetics have changed, but it takes away the grid lines. And later on, when you zoom in and zoom out, because of that, it's no longer treated as a quantitative. You see that some differences in there as well in how you trade the types. And also, it makes sense here that it's ordinal, because later you do some sort of aggregation, and you can't really aggregate over quantitative scale, but you cannot aggregate over ordinal. So let's talk about all those different types. And I think that looking at the data is very crowded, because each country would have multiple observations from 1955 all the way to year 2000. So there's 2000 minus 1955 divided by 5, because it's increment of 5. That's a lot of observation. So what I also want to do is I just want to very quickly create a smaller subset of this data. So I would say I want only the year 2000 observation for each country. And so how do we do that? We say df year 2000. You could type the whole thing. You can say 2K. So any of you who grew up, who's young enough or old enough to grow up in the Y2K era, the Y2K stands for year 2000. So 2K comes from that. I'm going to just say df, and I'm going to subset df. I want to take where the year is equal to year 2000, right? And I'm just going to see how many of them are there. So year shape, and so there's about 63 countries. That looks about right. If you do a quick df dot country describe, you should see there should be 63 unique as well, right? So you just delete that. So we have 63 different rows, and we're gonna now change this. We're gonna just use the 2K, so we don't want to see the whole thing now, just to see. Okay, so that's it. So it'd be interesting to look at what countries is this. Very high fertility, it belongs to cluster 0, and then we see that cluster basically it doesn't depend on that. Pretty much doesn't. That you could make an argument that okay, there is some relationship here, and that a lot of this fertility they belong in cluster 1. They are in this scale. Cluster 0, that's in that scale. But then you have cluster 2 and cluster 3. Well, cluster 3 comes to this scale. Cluster 2. So is there a relationship between cluster and fertility? Not really. So we need to poke further into the data. But let's stop here a little bit and talk about the different data types, right? When you look at, I mentioned all of this before in the earlier videos, but let's assume that you did not see them, right? So let's say nominal. Okay, nominal, that's basically encoded as an N. You will say something like capital N. So all this encoding that when you're doing this encoding, you want to use the capital, right? And all of these are shorthands. If you watch the earlier video, you know all of these are shorthands. Now, nominal data, what are they for? They're actually going to be for categorical data. And they are not ranked or not sorted in any way. They're just categorical data. All right. So they consist of category names, and nominal data. You can compare the equality. For example, you can say that is country Indonesia versus country Singapore. For example, is that the same, right? So in this case here, if you were to encode country in here, you would use nominal. So if I were to add a color in here, so let me just do that. alt.Color, and I want to put country, and then that would be nominal, because you will see that each of this country, they are just a nominal field. Is Afghanistan the same as Argentina? No. But is it greater than Argentina? Not really. It's not meaningful to compare that way, right? It's not. For example, if you have a category data and you say have like hot, medium, and low, is hot greater? Is hot greater than medium? Yes. Is medium greater than low? Yes. There is a rank to it. But nominal itself, there's really nothing nothing as such. So there is like Australia and Austria. Is one greater than the other? Not really. All right. So how do you what kind of encoding do you use usually with nominal? So I typically use something like coloring. Color makes sense. You could have like positioning of that. You could make sense. Shape also could make sense. So there's something called a shape, which you haven't really seen. But you see all the different shapes in here. It gets repeated, so after a while it gets too much and it repeats. But that's also something that you could use. There's one way you could encode nominal data. But what is it that you don't use nominal data with? What are some encoding style? What are some channels that you don't use it with? So one example is size, right? You don't want to change this. You don't want to use size because it doesn't make sense. It makes no sense. It's not rank ordered. And here you see that here it's just going to rank it based on the alphabetical order, but it makes no sense. The fact that Afghanistan is the smallest because of that. So you want to have a good sense of like what would be the right encoding type for each one of them. All right, nominal type, categorical type. Color is okay, shape is okay, but definitely not size. Then the next one I want to talk about is ordinal. Now ordinal sometimes it's a bit confusing between nominal and ordinal because ordinal could also look like it's a categorical, except this one is a rank ordered, meaning it has a specific, the ordering has meaning, right? Has a meaningful ordering, right? So these are like hot, medium, cold. These are things like slow, fast, and static. These are things like risky and then safe. Like let's say investment, risky investment, medium or average, and then safe investment, and interest guarantee. The principal guaranteed investment, which is the safest of them all. It's just guaranteed your principal, right? So these are ordinary, that there is a sense of rank order between the values. So you could say something like my principal guaranteed investment mode, right? Is that safer than, let's say, government bonds? Government bonds is very, very safe, but even then, principal guaranteed is just even safer. So government bonds come very close to being, as safe as it goes, right? But even then, it's not safer than principal guaranteed. There is, you could actually make some sort of argument about, of all these different categories of bonds, or of these different categories of investment, which one is safer than the other. It makes sense to compare them in that order. There is a meaningful ordering. This is not the case with nominal, right? So when you see O, when you see encoding O, that's what it means. And so if I ask you what would be a good way to encode ordered value, so what would be a good way? You could use a lot. There's a lot of good answers here. So you see me use this Altair Y, which is to just sort of have it on the position. So whether it's the higher, the safer, the lower, the less safer. You could do that. You could use the size for that as well. You could change the size. So the size basically goes like it's larger. So let me change that to size. Right, the larger, the safer, the smaller, the least safe. You could also do that. You could also use color value, for example. You could also use opacity, for example. There's a few ways you could use to sort of encode ordinal values, ordinal data types. And then now we talk about Q quantitative. Let's actually take away this one. Let's take a look at quantitative. Now, quantitative is encoded. Let me actually use the quantitative just as a sort of as a note here, right? Sort of as a note here. So quantitative, this allows you to measure numerical differences between values. So any kind of number that is quantitative would be numbers that allow you to do basic arithmetic. It makes sense to do basic arithmetic. For example, right, if you look at this, it makes sense. You could use something like 34.020 and minus 31.997. You could do something like that. It makes sense. You cannot use Afghanistan minus Singapore. It doesn't really make sense in that way. You couldn't really use like risky. You couldn't say risky minus less risk. It really doesn't make sense to do it that way. But it makes sense to take this and then let's say this one, population minus this one, and you say, well, the difference of that, right, is this value, 10 million minus 9.8 million. And it makes sense to sort of compute that arithmetically or numerically. So quantitative allows you to do that kind of arithmetic. You can measure the distance between different points. You could say, what's the distance between point number 3, which is this one, versus point number 5, which is below, or point number 0. You can do that. And then form the conclusion that point number 3, this point here, is about 6% larger than point number 2. You could make conclusions like that. You could form statements like that. This allows you to do math on it And when you encode something in quantitative, the first thing you notice is that it adds a 0 as a baseline. So let me change this back to Q and show you what I mean. You see that there's a 0 that is added in here, and there's a 0 added in here because both of them are quantitative, right? So when you use Vega or when you use Altair to do this, it would, on the axis, if it knows that if you denote this as a quantitative data type, on that axis it would just add a 0 baseline because it feels that it's essential for proportional comparisons of ratio values. So you could see that, okay, 0.0.5, that's scaling up by 0.5, and then it scales up by 0.5, it scales up by 0.5. Here, same thing, 0 to 1, it scales up by 1, it scales up by 1. So it adds a axis with 0. But if you change this back to ordinal, you see that now it doesn't care about that, right? It starts all the way, and here it gives you all the different classes, but it doesn't try to display that the way that you see earlier about quantitative, assuming that's like a scatter plot where quantitative against quantitative. You could observe, you could measure. Instead of observe, you could measure numerical differences between values. That's kind of what I was talking about. You could do math on it. You could say 34.020 and then you could say minus 31.997. What's the difference between them? But then the last one, let's actually add that temporal t. You could safely assume that it's about timestamps, right? It's measuring timestamps. So these are timestamps. They measure they measure time points, they measure intervals, and when you encode something as temporal, you can then use Altair's very rich date transformation system, date time transformation system, to sort of encode using months and days and stuff. A lot of those things you see them in the first notebook, in the first video. Okay, we're also gonna see more of them later, but right now in this data frame that I'm using, we don't really have that. In the earlier data frame that we use, we see them. You see that there is the month, there is the I can do this, the month start time, because start time is encoded as a date time and temporal. So you could do that. But in this case here, we don't have that. It's safe to say that the temporal timestamp that allows you to measure values that could be measured in time points or intervals. Alright, so let's maybe copy of this without all the comments. We're just gonna leave that one up there because it's easy, sort of handy to have somewhere to refer to that, to reference that. So I'm gonna keep that up there. We don't need any of this anymore. Now you see that this is quantitative against ordinal, but let's just put a quantitative against quantitative so that you can compare the two plots side by side, right? So let's find one that is also quantitative. Let's say the life expectancy, because life expectancy is also quantitative. We could then see how does it look like with a plot with quantitative against quantitative versus a plot with quantitative against ordinal. So that everything makes more sense that way. So let's go ahead and say life expectancy, and this is going to be a quantitative. Let's do that. And now we see this is kind of like a scatter plot, and now we see grid lines on both sides. And also we see that both of them, the 0 will be on the bottom left, which makes sense because when you plot a scatter plot, you want to have 0 and then you want to go to the right. This one you go from 0 all the way to the north, right? So the higher the value, the higher up it goes. The higher the value, the more rightmost it goes, right? So that's kind of the relationship between them, and this is typically called a scatter plot. Okay, so let's go ahead. A scatter plot is when you plot a quantitative against another quantitative. And why do you use a scatter plot for? You're trying to find relationship. You're trying to see if there's any kind of like linear relationship, any kind of a relationship that you can model at all. You see that, okay, as fertility goes, increases, and life expectancy starts to drop, and you can see that there's kind of a not perfectly linear, but you see some relationship in there. There's some correlation in there. All right. And then of course we talk about the 0, that's the baselining. It allows you to properly baseline that. Imagine if you don't start from 0. Imagine you start from 30. Well, now you're going to skip instead of 0, 10, 20, you have 30, 40, 50. So now there is no more baseline. You don't know what value of 0 would be, right? So a 0 baseline, it could or could not be meaningful. If it's not meaningful, you could turn it off. If it's meaningful, you want to keep it on. A lot of times I keep it on, but to turn it off, to show you what it means to turn it off, let me change this, and I will add here, and I'll say the scale. And I could do the scale. You've seen this before as well, but let's go ahead and just do alt.Scale. Now, in the earlier videos, when you see alt.Scale, you see me use title to sort of control what the title would be here. But you could also pass in another parameter called a 0, and you can say forget about the 0 baselining. So 0 equals to false. Let's actually copy that, and let's do that for the y-axis as well. So let's copy that, put a comma in here, and let's run that. So what do you see now? what you see is that Altair is now you disabled the automatic inclusion of 0, and now you configure the scale mapping, and it still try to find good values for it, except now you no longer have to hold the 0 baseline, but the padding still remains. You see 40 to 45, that's an increment of 5, right? 45 to 50, 50 to 55, 60. So the intervals is still a regular interval between them, right? 0.5, 1.0, 1.5, 2.0, all the way to 7.5. But if you take away that extra space between 0 to 40 and 0 to 0.5, now you see that this relationship is more linear. You could maybe more clearly see it. With this axis actually snapping to intervals of 5, 40, 45, 50, 55, this is actually good, right? But if you were to change this, let me go to alt.Scale. You want to turn that off as well. You could say nice equals to false, and now it doesn't try to snap them perfectly. You see that there's 45 is here, but then there's some in here, and it's not perfectly snap to that number. There's no 40 anymore, right? And 50, 55, but you see that the 80, and then it got cut off again, right? So that's what the nice is doing. This one, it tries to snap it perfectly. It says that, well, I should stay at a 40 so that you could visualize this point being between 45 and 40, and then 80, I could add 185. So that's kind of what nice equals to true or nice equals to false is doing. Same thing here, you could also try that. And you could see, again, it doesn't try to give you a perfect value. You see here, 1.0, but it starts at about 0.9. So it's not great, right? But you could see that, okay, there is one data point in here, and you could only assume that it must be close to 1.0, but maybe not. All right, so extend it off as well. Rerun that, and now you see it's around that 0.9, but I think this is a little bit nicer. Well, we could also try to add a third dimension, and that's the, let's encode something. Let's encode something for the size, right? We want to use the size. We want to say alt.Size. And let's find something that is quantitative here. So country is not, year is not, cluster is not, population is quantitative. So we could use population because we want to have something mapped to size. We could also use an ordinal rank, which means cluster is fine too. But probably size population makes more sense. It's a better fit for that example, for this example. So we're going to map to population. So we're going to say that each of these points here, we want the size of this channel to be mapped. So this basically control the pixel area. All right, you want a pixel area for each one of this point to be mapped towards the population. So a larger population takes a bigger pixel area. So let's run that, and we'll see this. That okay, there are big countries. You can see that there some of these countries you could probably guess, right? This is probably China, this is probably China, or this is probably China. If this is China, then this would be India. If this is China, then this would be India. And then maybe Indonesia is somewhere in here. It's the 4th largest country by population. Then you could try to sort of find relationship as well between the size of a country population and life expectancy and fertility. You can see if there is any kind of a relationship between them. And also because we map this alt.Size, this Altair size, what it does also is to include a legend for you to interpret the size value. You can see that any value, anything that is of this size will be 1.2 million and above, and 1.2 billion and above, right? Anything of this size will be 1 billion and above, and 800 million and above. So on that scale, I guess Indonesia is not even that big after all. But then a lot of countries, a lot of them, they are so much smaller than, they don't even reach this size of 200 million population, right? There are not many countries that reach 200 million. There are maybe 6 countries that reach this size. So we would want to change the scale of that, because otherwise it makes very little sense in that most countries, if you look at most of the points here, they're not even at this 200 million mark. Meaning most countries do not even have 200 million population. There are less than maybe 6-7 countries that has 200 million population. Indonesia do have 200 million population, but the scale here clearly are skewed towards the high range, and that is gonna cause the size to be, you see all the big ones, but then all the small ones are just way too small, right? So how do you fix this a little bit? How do you change this to be a little bit better? Well, there are a few ways as well to do that. Okay, I'm gonna show you probably the easiest way, and then later on, as we build along the other future lessons in this series, then we're gonna see 2 other ways. Actually, if you watch my other videos, you would already see me do in one of multiple ways. But I'm gonna show you first right now. If you are not happy with the default size ranges that it provides, you could change the size range to be any value that you provide. So for example, we could say alt, and we could say alt.Scale. And now in here, we already seen 0, we already seen nice, we already seen title, but we could also say range, and we pass in our own range. So this range here mind you, these are all pixels. So you could say I want to have something between 0 pixels to, let's say, 1500 pixels. And let's run that. And now you see that the 1500 pixels, they are a lot larger, and then the 0 pixels is still small. But this doesn't change anything in here. It doesn't change that, but it does change the visualization of that. And now it's a little bit clearer what are the big countries, and you can see them a bit better. Well, now the other thing I wanna, so we covered X, we covered Y, we covered size. Well, another one that's quite common that you've seen we use quite a lot, but I haven't really spoke about that in any kind of depth, is color, right? So let's go ahead and do color, because we all love colorful plots. Colorful plots makes the plots look brighter, it gives some semantic meaning to it, it's easier to understand, and it communicates a stronger message. So let's add color to it, and let's map the color to, I want to show you about color first. First of all, color, depending on what you specify in the encoding, it could assume two types of color. First one is the color gradient. Now, a color gradient is where something is continuous, right? So for example, if you were to map this to population again, and you say quantitative, now you see that this is a gradient. It goes from very light shades of blue to a darker shade of blue. And the larger it is, the darker it is. And the lighter it is, then the smaller the population is. So when you map a quantitative data type to color, you are going to get a gradient. But if you map something like an ordinal or something like a nominal, so something of, let's say, country or cluster, let's actually use cluster. Let's use cluster because both are not numeric. That's good enough. Let's say nominal. Now you see it's no longer a gradient. Instead, these are distinct color. So depending on what you specify here, okay, if you specify like nominal data, you get distinct color scheme. You get a color scheme. You can change all these colors to be your own color, and you've probably seen me do that in other videos as well. We haven't reached there yet, so it's fine. But this is what happens when you encode the color with a nominal data type. All right, and you see what happened earlier when I specify a quantitative is that you're gonna get a gradient, allowing you to sort of perceptually order the colors and say that, okay, the darker colors refer to something, and so on and so forth. Let's change that to fertility. Let's see. See that there's you see that there's the color gradient in here, and so the darker it is, the higher the fertility of the country and of that year, and the lower it is, then the lower the fertility of that country. All right. So let's change all of this back. I remembered, I think that's cluster, and that's a nominal. So let's change that right now. So I spoke about this in the earlier video. I spoke about the mark point and the mark circle, right? And you see that the difference is that mark circle will fill the color in instead of the mark point. Mark point will just give it a border. So let me show you that again. And you see that the mark point will just give you the border. Mark fill will just color it in. And it turns out you could also use mark point. You could stick to mark point, but you could also then pass in fill equals to true, and it will still do the same thing. So mark circle is kind of, you can think of it just as a sort of as a shortcut to that. It just like it's a shortcut to, instead of having to type mark point fill equals to true, you could just have done mark circle. That could have saved you some typing as well. And if you use mark circle or use mark point field equals to true, and you pay attention to your plots, you realize that by default, Altair would apply some level of alpha, meaning some level of transparency, to help combat overplotting. So if there are multiple circles in here, multiple points in here, they are overlapping each other, but because of the little bit of transparency, you can see that you can see through the first point to see the second point in here. I don't know if this is too small on your screen, but hopefully you get what I'm saying here. And this opacity value, you could also map to something. You could, for example, say something like opacity value, and then you could pass in and map something else to it. In this case here, I think it's a little bit too much now. I'm just going to put a fixed value to it. I could say something like 0.4, and that is just specifying a fixed number instead of trying to map it to another encoding channel. So there's no binding. This doesn't bind to any sort of data type columns. It doesn't bind to any specific columns in the data frame. It's just a fixed value. And probably the last encoding channel that we're going to talk about, or actually we're going to focus on, is the shape itself. So we could use alt.Shape, and again we could give it a fixed shape, or we could just map it to another sort of another variable. So let's take a look at this one. You could map it to a country, but there's a lot of countries. There's 63 countries, so we're gonna get 63 shapes. That's too much. Cluster, there's only 5 clusters, so this is kind of great. 6 cluster, I think. So let's just go and use cluster again, and again map it to nominal type. And so let's run that. And now we have the shape map to that. So what do we have here? Let's summarize that a bit. We have X, we have Y, we have size, color, opacity, right? We have shape. It turns out you actually have seen tooltip as well. We actually used that in the earlier video, but we didn't have that today, but that's okay. Actually, we could have that, no problem. To say tooltip, and let's just give it a name because we haven't mapped the name to anything, right? Let's just say the name, and let's just say the population. Put a comma. So now you have a name. Okay, that's China, as we guess, as we correctly guess, and then that's, I think, India. See, that's what we correctly guess as well, because they do very dominantly. You can see the size of that, very different from almost any other countries up here. So that's China. It has a higher life expectancy, slightly lower fertility, not slightly, but quite considerably lower. And India has slightly lower life expectancy, but higher fertility. And let's take a look at Pakistan, even higher fertility. What about this one, Nigeria? And I think actually, but by this point, if I stop here a little bit, I think you could sort of have a guess about what the cluster what the cluster means now. Earlier we were trying to guess, what could cluster mean here. And now that you see Japan and China, they have the same shape, and you see like United States and Mexico, they have the same shape, and India and Pakistan have the same shape. South Africa, Kenya, and Nigeria have the same shape. I think you could kind of guess. Rwanda is here, so you could kind of guess like what the cluster actually refers to now. That we are gonna probably see. You could set some sort of ordering as to how you want the different lines or area or point. There's also order, and then there's columns. This is for faceting and rows. Okay, so columns and rows are for faceting. I use terms like faceting because I think a lot of say people who watch this channel, you probably come across like a ggplot or plotting in R, and you're probably familiar with the system and you hear of that term. If you never heard of the term, then you probably heard of the term called subplots, right? So these are trying to create like subplots, but we come across those later, and we discuss them in further details later. I could go on and show you another example, but I also I was thinking about this. Like earlier, if you see me do this, India, and I was trying to look at this country, and I couldn't. My mouse just wouldn't hover to that. My mouse would just stop at India because it's on top of the other country. You see that? So this is what order could fix for you. Order determines the order of the data points, and if it affects, because it determines the order of the data points, it also affects the order in which they are drawn, right? And if you try to do a line plot or an area plot, it also changes the order in which they are connected to one another. So if you have data, typically you wanna, if you do some sort of data analysis workflow, you would generally try to order them and rank them before you actually put them into a visualization system. But you could also just change that on the fly with Altair. Now let's actually go ahead and fix this one first. Let's go ahead and maybe sort them so that order them so that it starts from the smaller countries should be at the closest to us on our screen. So meaning we want to order them first, and then that will change the ordering of that. So instead of, let's make this more concrete. 100, 40, 30, and 30, 40, 100. Okay, if I do not order them, I'm gonna plot the 30, and then I'm gonna plot the 40, and I'm gonna plot the 100. So what's gonna happen is that the 100 data points is gonna be at the highest. It's gonna come at the last in the order. And because of that, it's going to be at the upmost, the highermost layer. And because if it's in a highermost layer, my mouse is never going to be able to point to this. It's only going to be able to point to this one because it's the highermost layer. So imagine them as like Photoshop layers, or imagine them as ggplot layers. Or like if you're familiar with working with CSS, imagine them as Z indexes, right? So Z indexes allows you to control at what layer which one goes on the plot first. So what I want to change this into this 140, 30, because then I plot my biggest points first, then I plot my second biggest points, and then I plot my third biggest points. So that way I could then point to the smallest one, which is this one, and I could still see a tooltip. All right, so that is kind of the ordering. And let's go ahead. How do I change the order so that it goes from 30, 40, 100 to, how do I change this to this? How do I change this to this? So to do that, you could just say order, and then you could put a descending. So you could say alt.order, and you could say let's order by population, because the problem here is that it's due to the population, is that India is plotted first, plotted last, so it sort of cover everything behind it. So let's plot population. Let's say order by population, but then change that to sort by descending. All right, and move this upwards. Put a comma there, and then now let's run that. Okay, now we could see Bangladesh, and then we could see India. right? And now India is plotted first, and then Bangladesh is plotted later. And because it's plotted later, it's going to plot on top of that. So now you could point to it, and it wouldn't affect that. So that's what I wanted to talk about just now. If you realize that some of these points I'm not able to point because they are, covered by the bigger points because the population comes first. Let's talk about tooltip as well. So we see now we have India and we have the population. It turns out if you only want to see the country, you could have just done one country like that. So now you're only going to see country. So just a simple string. Okay, you don't even need a list for that, you just need a string. But if you want to see a list, that's what you do. And in fact, if you want to see more details about that, or you want to transform things on the fly, you could also do something like this. You could change this, and you could do something like alt.Tooltip. On some level, you actually seen me do something like that when I'm trying to get the month. So I could do something like transform right on the spot. I could say something like take the month of the start time. I could do something like that. But let's stick to this one, alt.Tooltip, and we're gonna still keep to country. So I'm gonna put country, and then we can put our encoding as well. We can say this is a nominal, right? You can change that. So we don't need this anymore. Let's take a look at what do we have? We have fertility. Let's take that. Let's copy all of this, and let's paste it in here. And let's copy this down, and also change this to sort of life expect. All right, and let's run off that. And now you see there is a country fertility of 1.7, life expectancy of 72, compared to, for example, Philippines, fertility of 3.5 and life expectancy of 70. So they do there's more kids per family per woman, but it's about the same life expectancy. So we have taken care of the order. We have columns and rows that we have yet to talk about. So let's talk about the columns and rows now, right? So let's take away this command, and I want to add a comma to it because we're gonna have the columns. So earlier I said that it's kind of like creating a facet or creating a trellis plot. If you understand like the if you come from the R system, you probably heard of a trellis plot. You've probably heard of like facet. If not, think of it like subplots. All right. But what columns and rows allows us to do is to sort of encode a different channel, so that each unique value would then be in its own row or be in its own column. So let's just do one example, and you could see it more visually. Let's change that to cluster, for example, and let's say cluster n. This is complaining because it doesn't like the name parameter before this. So you could either move this up like this, you could move it up like that, and okay, now we have the columns. So I moved tooltip all the way to the bottom so that I could use the name arguments. You cannot, this is not an Altair thing, this is a Python thing. You cannot have your name arguments before any of those unnamed arguments in here. So the name arguments have to be at the bottom. All right, so column, okay, cluster. Let's take a look at that. So now it's gonna create a new column for each cluster. And now it makes a lot more sense because now it's quite clear that each one of them refers to a region. So China, North Korea, Japan, Philippines, Indonesia, and South Korea. What I'm actually surprised is that Indonesia is not a lot larger than Philippines because it has a much bigger population size. But okay, you could also change this to row, and now each one of them would be its own row. All right, so that's kind of the row and the column. So change that back to column. We don't need all of the tooltip anymore. Let's just say all.Tooltip. We just want to have country. Country is all we need. Of course, we have to remember to give it a nominal. Okay, but if you see that this is running way too wide, you could change that using properties. We've seen this also previously, just very briefly, but you could say properties and change the width and height. And so let's say the width is going to be 150, and let's say the height is still going to be 150. So let's run that. So now you have width 150, you have height 150. You could say height is equal to 140, and width is kind of like, I don't know, let's keep that one. So yeah, it's kind of okay. It's okay. It's not great, but we keep to that. So you can tweak this as much as you want. You could play around with the figures, try and change things out. You see that when this is already wide, a lot of the legends is taking up even more space than it's really needing because it's already using a lot of width here. So what we could do is to switch the legend to move towards the bottom so that it doesn't take even more width than is required, because all the width is so precious because you're using each cluster. each column mapping to each of the cluster. So what could you do here to change this orientation of the legend to move it towards the bottom? So how do you do that? So first thing first, let's maybe pick one to work with, and then the other we're just gonna turn it off. All right, let's say the color. In fact, let's also just remove, I think let's just remove the shape. Let's rerun that. Let's still see there's still a few things. Okay, cluster is there. Let's change the legend now, right? Colors, I want to go into to cluster, and I want to just say legend equals to none. So I don't need a legend for that. Okay, so now there's no more legend. So now it's taking up less height, I guess. But population, we want to move that downwards as well. Want to move the legend all the way down. So this is where you could use the scale, and you could just put a comma. In fact, I think now that it's getting too much, let's maybe make it a little bit tidier by putting them into its own line. So scale is in its own line, and then we have legend as well. So let's set legend. If you set legend equals to false, it's just going to turn off the whole thing. What if you just want to move it towards the bottom? You want to say, oh no, I don't want it to be on the right, I want it to be at the bottom. So you can say legend, let's spell that correctly, and say alt.legend, and you can say orient, which is the orientation. We want to say go to the bottom, and then I think that's kind of it. If we run that, okay, now it's moving to the bottom. There is this title called population. You could either switch it off, or you could just move it to the left as well, so it doesn't take 2 rows, it only takes 1 row. So how do you move it to the left? So you say title orient, and move it to the left, run it. Okay, now it's moved to the left. You could also move it to the right, and now it's moved to the right. Now you would think, could I use the same column technique for the year? What happened if I use this and I map this to the year? So instead of column, I map to the year. So what's gonna happen is you're gonna get a lot of, right? Let's say this is ordered. Okay, you're only gonna get year 2000 because we only use the year df2k. But if we change this to df, now you're gonna get all of this, and that's a lot of data going on, right? So 1995, 1960, 1965, 1970, 1975, and it's gonna keep on going just like that. And this is probably not going to be very useful anymore, because when there's so many of them, and there's so many of them next to each other, it gets too much. It gets a little bit confusing. So how do we fix that? So let's go back to 2k. Let's change this. I'll tell you what, to save you some typing, I'm just going to copy all of that, and I'm going to delete the parts that I don't need. I don't need the properties, so I'm going to delete that. I will change this to df, and I'm going to take this command out. I'm going to change a couple of more things, but let me see. I need the fertility, I need the life expectancy, the pop. Cluster is fine. Opacity value, that's fine. Order, I don't need the columns, so let's take that out. And let's just run all of this. Okay, so I'm looking at all of this different data, and let me just take a look and make sure everything is fine. I realized that the tooltip, the country is not showing anything because I didn't spell that correctly. So I want to spell that C without a capital, C without a capital as well. And then I want to rerun this part, and I want to rerun this part. Before that, it was cluster n. So let's do that, cluster n. Okay, that still works. Tooltip should still work, right? Yep, it does. Okay, so we could change this a little bit by giving it instead of having to plot out all the different years, because there's going to be way too many. One way you could do that is to think about, like, how would you show, what would make sense, what would be a good user experience to visualize the transformation over the years without having to plot everything out at once. So one thing you can do is to sort of filter it first. You said filter for the year based on what the user is selecting. So we first need to create some sort of a slider at the bottom. We want it to be a slider where somebody could select, like, I want to look at the year, for example. All right, I want to say that, okay, I want to see year 1955, I want to see year 1975. That's going to be a slider, that's going to be a selection where the user could make. So here I could just say something like year slider, and it's a selection that the user can make. So I want to say selection. Now earlier in the earlier videos, you see me use selection interval. You see me use selection interval. Interval allows you to select like an interval. I want to say like between March and April and May. I could do that, right? I could say drag this. I could go through different intervals, and I could see that. But in the year slider, you could only ever select one year. I want to see what it looks like during year 1975 or year 1998 or 95, right? So this is a selection. Instead of an interval, instead of this, which is what we used before, we're gonna say single. Okay, and I want to give it a name. I could give it any name. I'm just gonna call it select, and I would give it a the fields. So these are what I want to select. This is what are the columns that you could filter by. And if you look at it, the name of that column is called year. So I want to be able to point that to year. So in the fields of that would be the year. You could also give it an initialized value, a default, the initialized, when before the person have changed, before the user have changed any of the values, what would be the default value of that? And so I'm going to map that to year, and I'm going to say the default should be 1955. That's the first year, all right? The first value right up here for 1955, and then it slowly goes all the way to year 2000, I think, all right? So we have that, and then what I want to do is I want to take this and allow the user to have a range that goes from 1955 to the maximum of year 2000. In fact, I don't even know if that's actually the correct one. Let's take a look at that one. Let's say df, and let's say year, and let's say max. And what is that? 215. Okay, so let's close that out. And so we have a step of 5. That's increment of 5. Okay, that's cool. So we have this kind of, this is a selector. Now what we want to do is we want to bind that selector to this plot, right? So we're going to say add selector. So we're going to say add selection up. This is add selection. So what do we name it? We name it year slider. So let's do year slider. And then depending on this selection, depending on what the user select, you want to transform. This is similar to the flow that I showed you earlier when there is some sort of brush. But depending on what the brush is selected, depending on what is there, you want to do something with it. So here we want to say, depending on the selection, you want to filter. So you want to say transform filter. And transform filter what? The value that is being selected by year slider. So say year slider, put that again. Like this. Just run all of that. And now we have a year slider at the bottom. And if we move 1955, 1960, 1965, 70, 75, 80, 90, 95, year 2000. So depending on where the values is, this selection is going to add a filter, and the filter is just going to take the year, right, and say that, okay, does the year equals to 1955? If it does, then display that. And this one would then say, okay, if does the year equals to 1985? If it does, then apply the filter. So that's kind of it. That's kind of that's another way to present your data instead of actually having to rely on, you know, just the static row and columns. So this is kind of also one of the reasons why Altair is so powerful and why Vega Lite and Altair is kind of the chosen library for this curriculum. Now up to this point, we've seen a lot of the points. Let's talk about the different kind of graphical marks you can actually use. All right. So let's go ahead and just let's leave this up there, and let's go ahead and maybe use a few. Create a chart, and then we change the mark here to look at all the different options for graphical marks. Altair has a very rich system that allows you to specify all kind of different marks, and so far we only look at mark point, mark circle. In the earlier videos, if you see me use like mark, I guess mark bar, this one mark bar, you see me use mark line as well. I've used the line as well. So you've seen a few, but let's go through all of them. Not all of them maybe, but let's go through 80-90% of the most common ones that you probably come across using it over and over again. All right, so let's go ahead. Let's start with creating a Altair chart. So passing the data. So let's give it the F2K. So only year 2000. Let's say mark point, right? And let's give it encoding. And for the encoding, I'm just gonna copy pretty much the same thing. Just copy X, copy Y, paste it in here. So I don't have to redo the whole thing, and I don't need the scale, so change that. And I also don't need this. And so what we're going to be doing is we're going to be changing this the different values to this mark underscore and then this thing here. So right now we're using the point, right? If we run this, we see this code here. All right. Then what happens is if I change this to, let's say I add a shape encoding, and I say cluster, and this is a nominal, and we run that. So I have all these different shapes. Now what happens is if I pass in the field equals to true, it doesn't just affect the point. It affects whatever it is that is the shape of the point itself. So if the shape is a triangle, the triangle is going to be filled. All right. To make it a bit clearer, I'm going to change the size to be a little bit larger so you can see them. So I'm going to say 50 so you can see them. And now, let's say 150. Now you see it, right? So field equals to true, it doesn't just change, it doesn't just affect things because it's a round point. Field equals to true would just fill in the shape as well. So you see that all the different shapes in here, all of them are going to be filled in, and the size is a bit larger as well. So the size basically, again, this is all pixel area. All right. So 150 depends to that points to the pixel area of the point mark. All right. if you take away the shape and you just run this, now this is the same as removing the field equals to true and just change this to mark circle. I mentioned about that before, right? That's just a convenient shorthand for typing points and then saying that the field equals to true. So let's run that. It's the same thing. And if you add your shape, and your shape is basically cluster, because you have a mark circle on, the shape is not gonna take any effect because the mark circle is there. So if you change this to mark point, okay, now you see all the different points again. You see all the different shapes again. But you change that to circle, then your shape will not have any effect. Same thing if you change the circle to square. See, now all of them are just gonna be square. Another example of this, now we don't need the size anymore. We could also take a look at, so we see the mark circle, we see the mark square. Another one is mark tick. Tick is also gonna give you a tick without, and the shape again is not gonna be take effect. So mark tick is basically just a simple tick in here. This is good for a very minimal plot for when you want to compare data points using very short line segment and you have very limited space to work with. So you want to have a tick, kind of like a punch card. You know, I'm going to say like, oh, this person is present at this time. You could use that. It could also be very useful for if you only have one single dimension, so only have the x-axis without the y-axis. And so if you only have the x-axis, you want to be precious about the space you use. So and if there's very little minimal overlap, then this could be also a pretty useful, pretty versatile plot for that kind of plots you want to create, right? So if there is not a lot of overlap, if there's a lot of overlap, so then there's probably better ways to visualize that data, all right? Another example, let's change this to, let's take away all of the shape. Now we don't need the shape. So we've seen the circle, we've seen the square, we've seen the tick, we've seen the point. Point basically is the one where you could use a shape to change the shape of that. Everything else, if you say the tick, the square, the circle, they just gonna assume that shape already. All right. Let's change this to, let's say, give it country n because that's a nominal, and let's say population because that's a quantity, right? So population. And instead of mark tick, let's take a look. What do we want? We want on the x-axis, we want a country. On the y-axis, we want a population. What makes a lot of sense to visualize things like that? So what makes a lot of sense would be a bar chart, mark bar. So let's do mark bar. You could see all of these countries on the x-axis, and then on the y-axis is the population size. If you really inspect the if you go down to the Vega level and you inspect what happens beneath the scenes and what happened beneath the hood, what happened is this mark bar is really just a rectangle, so just really like a mark rectangular, except it takes that and it gives you the position, it gives you the width, and it gives you the height, and the height would correspond to the value of the population. So that's really what's happening. Now you would wonder, what would happen if I change this X to be something like, let's say this is cluster, right? So now I have cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. And cluster 4, this is the East Asia region. So this is where you have countries like, I think, China, right, Indonesia, Philippines. So China, Philippines, Indonesia, Japan. And you see because of that, the size of that, it sums out to be pretty huge, right? And then you see that the India is also pretty huge, but then I think it probably belongs to cluster 0. And then along with the rest of cluster 0, it also comes up to be pretty huge, all right? But I could, on top of this cluster and population, I could actually layer my colors on top of that. I could say that for each one of this bar, I want a color to map to something. For example, I could say something like alt.Color, and I will have this be my country. So now what it's gonna do is that it's gonna break each one of this bar, and it's gonna apply a country to it. So let me run that, and so you see all of the color, the countries, and you can see China. Let's actually have a tooltip so we can see that better, and you could say tooltip equals to country, and now you can see, all right, China is here, Indonesia is here, Japan is here, North Korea, Philippines, South Korea, and I think this is India. Yes, we are right. Bangladesh, Afghanistan, Pakistan. All right, this is Brazil, United States, Mexico. Right, so you could start to layer on top of the X and Y. You said, oh, on the X-axis I still want the cluster, on the Y-axis I still want my population, but I want the color to also be encoded into this plot. And Altair is not going to show you all the colors, it's going to show you all the top ascending order. You have Afghanistan all the way to countries with the name of Z, so Zimbabwe, and it stops somewhere and it says there's 34 more entries that it couldn't show you because it's just way too many. And Altair is also pretty smart about stacking the different bar marks so that each of the colors would then stack on top of each other and not over each other, right? Not on over each other. So if you were to turn this, let's say, if you were to say this stack equals to none, let's see what happens. Now you see that all of the stack, because stack equals to none, now it's going to be drawn on top of each other. So all the countries between this and that, from here all the way to here, all of them is hidden behind that China bar and you won't see it. And all of this is hidden behind the India bar and you won't see it. So stack equals to none, let's move that out. Now you can see it again. Now it exists again, right? So it's not stack equals to true. Basically, that's the default. That actually allows the different points of this population of the Y on the Y-axis to stack on top of each other. So it's going to be doing that automatically anyway. So in this example, we've seen that the Y itself, they encode this encode the value, and it starts from a 0 baseline, right? So the Y channel only encodes all the non-zero values, but it starts from a 0 baseline. Now, how do you specify? How do you create a plot with not a 0, but with a starting and an ending on the scale? So let me show you what I mean by that, right? So let me go ahead and just say alt chart again, and I'm gonna say the data 2K again. So that's the same data, df2K, I believe. All right, and I'm gonna use mark bar. I want to have the encode, so I want to have the alt.X, and let's use life expectancy now, and we want to say that's quantitative, and want to have alt.Y, and let's say that's just going to be the cluster of that's a nominal type. So let's run that. Okay, notice that the bar here, it starts all the way from the 0, right, the 0 baseline, and then it goes all the way to this point. Now, what if you don't want this to start all the way from 0? You want it to start somewhere. You want it to basically represent the minimum life expectancy of countries in that cluster and the maximum life expectancy of countries in that cluster. So, for example, in the cluster that has Japan and China, you want to see, let's say the lowest is China. I don't know if that's true, but let's say the lowest is China. You want to see what is the life expectancy of China versus, let's say, the longest is Japan. That one I'm fairly sure it is. So you want to see where Japan is. So you want to basically have this bar have a starting and have an ending and not go all the way to 0. How do you do that? And the way you would do that, right? Let me just show you what I mean by that. Okay, so let me say df 2K, and let me just go ahead and say life expectancy, and let me just describe that. Okay, so I have the minimum 42 and I have the maximum. So what I can do is I could, instead of using alt.X, I could actually have alt.X and then alt.X2, and then the maximum, this is 82, so we're gonna have minimum. So the minimum of life expectancy in each cluster. So I want to say life expectancy, and because that doesn't exist in the column as well, we need to give it a type, otherwise it wouldn't know what to do with it. And here you could actually do the same thing, just change that to maximum and do it like that. Okay, and so what this is gonna do is that it's now gonna plot out the cluster, each of the cluster 0, 1, 2, 5, and then it's gonna find the minimum life expectancy that is within each cluster, and then maximum, and then that's going to be the first X, that's going to be the X2. So X is kind of the starting point and X2 is kind of the ending point. So X, starting point of the bar, and then X2 is kind of the ending point. And that's kind of the range within each of life expectancy within each region cluster. So you see that the cluster 4, that is okay because I think there's Japan that is trying to pushing everyone up, but then there's the minimum here, and you see like cluster 1, and cluster 2, cluster 3. You can see all the different sort of regions, right? Let's talk about mark line. All right, so let's change bar to line. We could remove the comments here, Control K to remove that line. We don't want to have the. We want to just change this to year, and we want to change this to O. And also, just to see things a little bit clearer, we're gonna change also df2k to just be df. So we're gonna see all the different years, all right? Because then otherwise, otherwise it wouldn't make sense because the year, there's only one year because there's only year 2000. So we want to say that, change that back to df. And let's take a look. Y-axis, we want that to be the fertility. So fertility. So let's change that quantitative, and let's run that. So you see that this doesn't make a lot of sense because the fertility is very different for each one of this country, and because we didn't break them down into countries, so we see them zooming in and out, zigzaggy. So if we add a color to sort of this, make each one of this line a different color, so we say country, or you could, if the country is too much, you could just change that to cluster, And if you run that, now it makes more sense because each one of them would have its own country. And you see that generally speaking, most countries are giving birth to less kids over the different years. So 1955 people are having a lot more kids. Year 2005 people are having less kids. And generally you see that's true for almost every country. All right. You could then have your tooltip as well to sort of be able to pinpoint which country it is. And country, and let's run that. So now you can see, okay, this is what? Afghanistan. Rwanda, right? Kenya. So you can see that Afghanistan, Rwanda, Kenya, this is all okay. But you could, of course, change the width of this to make it a little bit larger. So you could say something like properties. And you could have the width equals to, let's say, 380. Okay, and now it's a bit larger, and it's probably easier to then zoom in and zoom out and take a look at each one of them in more details. If you want to have the line width to be larger, then you could change that using the stroke width. And the way you do that is in here, you can say something like stroke width. This is kind of like line width. If you use other kind of other programming languages, other kind of visualization system, they were gonna call this line width, but it's the same here. You can say stroke width, and now these are a little bit thicker, and you could maybe more easily hover across them. Change the opacity to be, let's say, 0.4, and now you can see it's a little bit faint. If you want the line to be a little bit smoother, for example, not have all these like harsh angles, then you could try to use some sort of smoothing by doing interpolation. So you could set the interpolation by doing this in the mark line. You can say interpolate, and here I'm gonna say monotone. We are actually gonna go into more of these details in future sort of sessions. This is only lesson 2, so we're just gonna keep to that, run that, and now you see that the lines are a little bit smoother. But when you smooth it, just know that these smoother lines are also guaranteed, are also guaranteed to generate some sort of false minimum and false maximum, just to because they're doing some sort of interpolation to connect the line so that they get a smoother curve instead of very harsh lines. So just be aware of that. If you want to compare, let's say, this same statistics, but you want to compare that across year 1955 to year 2005, and you only want to compare these 2 years, year 1955 and year 2005, how would you do that? So let's go ahead and just say df, and this is 95 to 205. Okay, this is the new data that we're going to create. We're going to say df, and we're going to subset. So we're going to say df where year is either equals to 1955 or, and remember when you do something like this, you want to put them in brackets, or equals to 205, right? So this is the whole data set here. And now you could use the same techniques here. You could say our chart, copy of that, paste it in here, and now you have 95 to 05. So these are only going to look at only the year 1955 and year, what do I name it? 95. I should name it 55. Okay, so 5505, and we don't need any of this, so let's just delete that, delete that, delete that. So they could just be in one line, mark line. And then now we want to see the year. It's still going to be correct. But now let's take a look at fertility rate, right? And the rest is going to be the same. So now you could compare them. You could compare, just year 1955 to year 2005. And this is kind of a slope graph. Some of you would probably call it a slope graph, right? And you can change that. You could change how much space out do you want here by changing the width. So for example, instead of putting a fixed width, I could say width, let's say step equals to, let's say 50, and let's see, now it's a lot shorter. If you say steps equals to 200, you can see that's a lot wider. All right, so the step value allows you to change this is going to indicate the size of discrete steps along the width of your chart. All right, we spoke about a lot of different types here, but let's also talk about the area mark. All right, the area mark. So let's go ahead and find Indonesia, and let's say in data, and we say data df country that equals to Indonesia. Shape. Okay, so 11, that's good. All right, so I use the shape to sort of make sure that I'm doing the right thing. If I see like 0, then I know something is wrong. So I'm gonna say Indonesia, and I'm gonna say mark area. I want to see over time what does the fertility rate looks like. So I want to say encode. So do women have more kids nowadays, or do women have less kids nowadays? So we're gonna say year is gonna be on the x-axis, and then we want to have y, fertility. That's a quantitative figure, right? So let's do that. We didn't spell that correctly, so let's change this to mark area, So now we see it. You can also have it being smoother. You see that there's still some harsh angles here. You can have it smoother, kind of the same way that you do it with a line. You could change this to have interpolate, and you could have this as monotone. So now it's a little bit smoother. And similarly, you could also change this to, instead of Indonesia, you could also change this to region, for example. So let's say DF, and we want to say color would be cluster. So basically, there are two different categories that they're trying to plot here. So the numbers go up and then it goes down again because there's a different country again, right? So we need to remove the country effect from it. So we either need to remove the country effect, or we need to remove the region effect. So one thing you could do is to have 3 countries of the same region. For example, you could have Indonesia, and let's see cluster, and let's describe, and it's basically 4, right? So we're going to take all the countries with cluster where this is 4. So we're going to say DF, and we're going to say DF where the cluster equals to 4, and we do a value counts because we need to have the country name. So I think it's called country, right? Yeah. All right. So China, Japan. Let's find a few. Let's do a few. So we're gonna just call this say cluster 4. Actually, just say cluster 4, would just be DF where DF cluster would that would be equal to 4, and now we could just say cluster 4, and now we could just have the country. Okay, now it works, right? So we accounted for the cluster effect, and we only look at country, then everything works. So we see that the stacking is also performed relative to a 0 baseline. But there are also other ways to sort of stack this out. You can also stack them in different ways. So for example, you could add a stack equals to center. So stack equals to center. And let's run that. And you will see now they stack towards that, and you say that, okay, here's the fertility, this is 45, but it goes towards here. And then 40, initially it's set out to be here, this is China, and then it goes towards here. So you could stack it that way. You could also normalize the values. So normalize, like this. And this will basically normalize all the data so that each stacking points will sum up to 100%. So you can see like, okay, this is China, it goes up from there, and then it starts to go down, and then it also increases a little bit, and then starts to go down, and so on and so forth. If you don't want to stack at all, then you could just pass a stack equals to none. But what's going to happen is that the country that got plotted last, which is, remember the whole thing about population. So it's going to come and it's going to be at the top of everything. So what you want to do is that if you want to specify something like this, then you could maybe have your mark area at a opacity at 0.4. So when you set an opacity of 0.4, at least you get to see through and you get to see what's behind it. Otherwise, you're gonna see this one big pink one on top of everything else. So you won't really even see all the other statistics. You're only gonna see Philippines, which is initially a fertility of 7, and then all the way drop down to 3.1-ish, 1 to 2-ish. So these are all the different options. I'm gonna go back to, let's say, center. I will just need this. Save that. If you don't want to stack center, actually let's think about another idea. I think we're almost at the end of this video now. Let's look at one more thing here. Just like how you could use the alt.X and then alt.X2, you could also do the same thing for alt.Y and alt.Y2. So an example of that, let me show you that. So I could say Y and Y2, and I could say, instead of actually having fertility, I'm gonna actually say this is take the minimum of that, right? And then here, take the maximum of that, right? And I don't really need the colors now because I'm just going to say the minimum of this cluster and the maximum of that cluster. And I could print off this. I forgot to take this out. Put it in here. Same thing here. Put it in here. So now I can see that. So we see a much larger range of values. Countries are more not alike with each other. So there are countries with 2, there are countries with 7 in year 1955. But as we come closer to 2005, you see that you know, the countries become more similar with each other in terms of fertility. So there's a lower range of values, and generally it has also declined to around 2 children, around 2 to maybe 5 children, 4, actually less than that, about 3 to 4 children, 3.5 children. So overall fertility values have started to decline. If you rather want to see this, you know, if you rather want to have the year on the x-axis and you want this to be on the y-axis, you could also flip them around. So you could say that the year, this should be y, and then these two should be x and x2, right? You could also do that. And then you just basically have the year being on the y-axis. And so that is kind of a quick tour of all the different building blocks of Altair. I'm not going to go into all of them. There's still a few other kind of marks that are pretty cool you can look at, but I'm going to upload this notebook now onto my GitHub, and I'm going to just end this at this point, because I feel like a lot of this stuff, if you practice with your own data set, you are going to, you are quite well equipped now to already explore this whole space of, using encoding and using mark types to create plots and to create good graphics. So in the next session, we're going to look at data transformation. That's also pretty exciting. So how do you transform data on the fly using what Altair provides you? And then you can create new derived fields from existing field. You don't even need them to be in your data frame. You could use existing data in your data frame to create new derived fields, and then use them to modify, skills, your encoding and stuff like that. So there's a lot of new concepts and new ideas. This is only we're actually at part 2 of the series. So in part 3, we're going to go into auto transformation. We're going to focus on that alone. So I hope you enjoyed the episode. Thank you for spending time with me. See you in the next episode. Thank you. Bye.